Thanks for joining us here today. My name is Court Shute. I'm a Chime Specialist SA with AWS. And Babu?
Yeah. Hello, I'm Babu Srinivasan, Specialist SA, AI Services. So in today's presentation, we would like to show you how to add AI and ML to the contact center of your choice, so you can deliver a better customer experience, improve agent productivity, and reduce costs. We all know that providing great customer experience is important. Let's take a look at some numbers to understand why. In a PwC survey report, 73% of the respondents said that customer experience is the third most important factor in their purchasing decision after price and quality. Additionally, close to one third of customers would churn right after just one bad experience. On the flip side, they said they would be willing to pay up to 16% price premium for good customer service. And yet, many companies still struggle to optimize customer experience, especially in the contact center. So, what are some of the common challenges in a contact center? Let's take a look at some of the common challenges that we keep hearing from our customers when we talk about their contact centers. First one is the long hold times. Agents are often tied up on other calls and unavailable, or it may take multiple transfers before a caller is able to talk to the right agent. And sometimes some of the calls take long times to resolve the issues. Even when the caller is finally connected to the agent is unable to resolve the issue either because the agent doesn't have enough information or has too much information and unable to direct the customer to the right solution. The third common issue is lack of insights. With contact centers, we do have a lot of data, but companies are unable to extract or surface insights from the audio data that are present in the contact centers. And they're unable to determine where to coach the agents. Today, many companies gather these insights through customer surveys, random call listening, and manual scoring. But this process usually captures customer feedback on 5 to 10% of their calls, which offers limited and often biased insights. The last most common challenge that we hear from customers is increased operational costs, time lost due to agents handling repetitive queries, and high agent attrition leads to increasing operational costs. The problem is that today we are utilizing legacy technologies that were fantastic a few years ago, but they aren't good enough anymore. So our customers are expecting us to deliver a great level of attention and customer service. So how do we do that at scale? So that's where we talk about the AI services. There is a challenge at every point in the contact center customer journey, right? From long hold times at the beginning to operational costs associated with long average call handling times. Fortunately, data is available at every stage of the customer journey, whether you know it or not. And AI/ML services can help you unlock it. The application of AI/ML can help boost customer satisfaction, improve agent productivity and retention, and drive revenues and reduce costs. So, what are some of the building blocks? Um, Underneath all these solutions are a host of AWS AI managed services or building blocks that help you add intelligence to your contact center. You can implement these services without needing to be a data scientist or a deep learning practitioner. For example, underpinning our self-service conversational AI solution is Amazon Lex. Lex is a conversational AI platform that can be combined with Amazon Poly text-to-speech voices to create powerful virtual agents. These agents help automate frequently asked questions and transactions. There's also Amazon Transcribe, an automatic speech recognition service that accurately converts all the live and recorded customer conversations into text. Amazon Comprehend uses natural language processing to detect sentiment, identify keywords and phrases, and classify calls. We'll extract all those key insights to understand what's going on in the conversation and make it actionable. Amazon Translate can help you, can also be used to facilitate conversations between agents and customers in their preferred language. Amazon Kendra provides contextual search for boosting bots and agent assist solutions with best answers from their internal knowledge bases. Now, AWS offers flexible contact center solutions. Amazon Connect is our single unified cloud contact center for voice, chat, and task management. It includes contact lens that provides real-time and post-call analytics powered by machine learning. But for those customers who have other contact centers, we have contact center intelligence solutions, CCI, that use a combination of AWS ML powered services for text to speech, translation, intelligent search, conversational AI, transcription, and language comprehension capabilities. Customers who already have a contact center can benefit from these AWS AI services to provide automated self-service capabilities, analyze calls in real time to assist agents, to also learn from their contact center interactions using post-call analytics. So when we talk about contact center intelligence CCI solutions, we talk about three large use cases. First one is the self-service virtual agents that includes conversational IVRs. And then the second one is the real-time analytics, where the conversations are analyzed in real time and providing assistance to the agents to serve the customers and help them resolve the issues. The third use case is the post-call analytics, where we analyze call recordings to surface insights and look for opportunities to improve customer experience and business opportunities. Now, we're going to talk about all these three use cases today. We're going to deep dive into these three use cases. We're going to go through some of the demos. Kurt will cover the self-service and real-time call analytics, and then I'll come back and talk about post-call analytics. Over to you, Kurt.
Great. Thanks for that, Babu. And now we're going to take a look at what the self-service virtual agents can do for you and how we can integrate those with your existing contact center. So why do you want self-service? So self-service can help you deflect calls, can help you make more intelligent call routing, and can help in a lot of ways that will improve your contact center experience. So we can use these self-service agents to reduce those wait times, to make sure we get it to the right agent first, to give you presence, 24/7. So these are some of the really nice parts about self-service and what they can do for your contact center and how easy it is for you to integrate those. So today it's pretty easy to get a chatbot into Alex. So you can take your SMS, you can take your Slack messages and get those into AlexBot so that you can provide text conversation with AlexBot. What we're going to talk about today is the ability to use a voice message. And so you can have an IVR that is set up on within your Lex and take a call in from the PSTN, so the publicly switched telephone network, bring that into the Lex, process it through the Lex with all the great features that Lex provides, the poly and the ability to make hooks into databases and things like that, and then pass that call. Once the Lex has finished, we can either end the call because we've successfully deflected it and we don't need to get an agent, or we can route that call to an actual agent with intelligence. And so we're gonna talk a little bit about Lex, what it is, how it works, and some of the key concepts here. So one of the big concepts here is an intent. An intent is it's an action that you want to do. So maybe you're going to do an open account or check balance or something like that. Those are different intents. You can build multiple intents within the same LexBot. Then we have what are called utterances, and an utterance is what a user says that will trigger that intent. So I would like to open an account will get you into the open account intent. At that point, the Lex is going to take over and it's going to try to figure out all of the things that it needs to complete this intent. And so with open account demo that we're going to show you in a minute, what you need to provide it is what type of account, a checking account, a savings account, something like that. And we're going to gather a little more information. What's your first name? What's your last name? Things like that. And once we have all of that information, we're going to either end the call and send that call back and say, okay, we've provided you the information that you called in to get. We don't need to talk to an agent, or we're going to send that to an agent. And here's where it gets even better is we're going to be able to provide the information that was gathered in that Lexbot to the agent so that we don't have to ask again. So we don't have to say, get your name again, verification, and all these other things. All of that information will be provided to the agent through the back end channels that we're going to show you. So now let's take a minute and we're going to show you what that demo looks like in practice. So what I'm going to do now is I'm going to call into my Lexbot, and I have a number that is provisioned with the Amazon Chime SDK voice connector. It's going to terminate that call, and it's going to send that call up to Lex. So now we're going to take a minute and we're going to make a call into that Lexbot. Here we go.
You can check your account balances, transfer funds.
Open account.
New account. What account type would you like to open?
Checking.
What is your first name?
Court.
What is your last name?
Shoot.
Is your phone number one?
Yes.
Thank you. Let me transfer you to an agent to open the checking account.
So at this point, we've now captured the incoming call and we're displaying that information on the screen for the agent to recognize. This information was captured within the Lexbot, and we're presenting it to the agent so that they don't have to ask those questions again. So one other interesting point about this was, if you noticed when the Lexbot was asking me my phone number, if it was correct, that was the number that I was calling from, and that is a number that was passed up to the Lexbot from the Amazon Chime SDK voice connector. So we're able to keep this information and pass that information between these different devices, all without having to ask for that information again, all without having to re-verify these things. And that's one of the powers that we have with the Amazon Chime voice connector combined with the Amazon Lex. Okay, and this is a diagram of what that looks like. So what we have here are all the different components that you would need in order to build a demo like that. So we're taking the call in from the PSTN, that's the public switch telephone network. We're gonna take that call and we're gonna send that call up through a voice connector into Amazon Chime PSTN audio. Amazon Chime PSTN audio is a service that it's like a programmable telephony. So we hook that PSTN audio up to an AWS Lambda, and we can control that call. So that's how we're able to capture information from the call. We're able to store that information in a DynamoDB, and then we're able to pass that information up to the Amazon Lex. At that point, the Amazon Lex kind of takes over, and we're not really doing anything within the Amazon Chime PSTN audio anymore until we end. And then we kind of tear everything down. And so the nice part about this setup here is we're only going up into the Lex for the duration of that IVR, for the duration of that bot. And once we're done, we pull that back and we keep that media path from your PSTN edge to your agent, however you have that constructed. So we don't need to hairpin calls. We don't need to tie calls up. If your PBX is capable of doing these data dips and this sort of complex routing, you can take advantage of that with the Amazon Chime PSTN audio with the Amazon Lex. Okay, great. And now that we've seen that interesting live demo, let's take a little deeper dive into what exactly a Lexbot is, how it works, and some of the things that you can do with it. As we mentioned before, some of the core parts of a Lexbot are going to be the intents. And in this case, what we have are 4 different intents. We have the transfer funds intent, a fallback intent, which is just kind of a default one, an open account, and a check balance intent. And these different intents can be used in different ways, and they're all triggered by specific key phrases to listen for. So if you start the demo and say transfer funds, we're going to go into the transfer funds intent. And within the transfer funds intent, we have a series of these are the utterances that would trigger it, and then we have a series of slots where we're going to try to collect information from the caller. So we're gonna ask them what your source account is. We're gonna ask them what your target account is, and then how much you're going to transfer on that request. The interesting part here, as you can see, is the slot type has an account type. This was a custom slot that we had created. And with this custom slot, we can reuse that slot over and over again to, for both the transfer funds intent, for the open account, for the check balance, and all of these things are gonna use that same account type, that same slot type. The other interesting part that we can do with Alexbot is that we can collect more than one piece of information on an utterance. So if you know that you're going to transfer $100 from a checking to a savings account, you can say that in one phrase. You don't have to split that up among multiple phrases. We'll collect that information from all of those from that one utterance and put that into each of the slots correctly. Um, this particular intent does not have a Lambda hook associated with it. However, the check balance one does. And we're just kind of simulating some data here. So we're not going to actually you know query a database or something like that. We're just going to make up a random number. But what we can do with this is once this is completed, we're done. And so, as we talked about with that deflection, what the deflection is going to do here is it's going to just hang up this call when it's done, rather than route it to an agent. So we can do the entire process of a customer fulfillment within a single Lex bot. We don't have to always go out to the agent, and we can make that selection dynamically. So if they use the check balance one, we don't have to send them to an agent. If they want to do an open account, that requires extra handholding from the agent. So we're going to pass them over to an agent. So this is a little something of how this Lexbot works. These are the intents that we're going to use. They get associated with an alias, and you can kind of go into some more of those details on your own. But this is the real power of the Lexbot is the ability to use multiple utterances to find the right intent, to gather information from that intent, and then to use deflection to not transfer to an agent, and then use intelligent routing to route that to an agent. I did want to touch on a few more things with regard to how do we get this call from the PSTN all the way up to a Lexbot. And as we looked at before, this is the diagram of what this looks like. In this particular instance, we're bringing the call in from the PSTN. In this demo that you can deploy yourself, there is a PBX that is an asterisk box. This is just an asterisk server running on EC2. It's going to make that call up to an Amazon Chime voice connector. And the interesting thing here is that this is going to be SIP. So we can take your existing SIP-based contact center. We can route that call up to a voice connector. And from there, we're going to route it up to a Chime PSTN audio service. And this is where we now start processing that. We start passing information from that PSTN audio up to the Lexbot so that we can process that there. And then when it comes back from the Lex, that's when we can start to make some intelligent decisions. We can add information into the DynamoDB and do all those good things. If your PBX, SBC, contact center system is not capable of some of these kind of more complex routing patterns, we have other options for this as well. So we have an inbound only. So this time we're taking that call in directly from the PSTN onto the PSTN audio service. And then when we're done with that, we're going to make a call out from there, as it's called a call and bridge action. And this call and bridge action will then send that call down to the voice connector and then over to the PBX. There's a slight change in how the call flow works, because I'm going to have to keep it tied up onto the PSTN audio service for the duration of it. So I can't give you back that media, but it does provide a nice and easy way to make a call in from the PSTN, deliver that to Lex, and then easily route that down to your agents. You could take it another step and in this case, keep your existing carrier, keep your existing PSTN service, route that up to us, and then we're just going to route it down a different path back to you. And these are all options available within the Chime PSTN audio. Part of this is you can kind of just be creative. So we have lots of ways of routing, we have lots of ways of manipulating calls, and we can probably figure out a way for you to take this call from what you have today and route it to your agent with a Lexbot added. So that's all we have for the self-service demo. Now we're going to talk about the real-time call analytics and agent assist. And what this is going to do is this is going to help you capture information, alert and managers and supervisors for potential problems that a call is having. We'll get sentiment analysis. It's a really powerful way to add these AI features into your existing contact center. So why do you want real-time call analytics and agent assist? We want to help the agents as much as we can. So we want to take that burden of taking notes off of them. We want to enable the supervisors to be aware of calls that have a negative trend so that they can proactively engage on those calls. And so we can get that with this real-time call analytics, where we're going to take all of this information as these calls are happening, transcribe it, and then produce sentiment analysis off of that. So these are the kinds of things that we can get with this. So we're going to use transcribe, we're going to use comprehend, we could use Kendra, we could use translate, all of these AWS AI services to get the turn-by-turn transcripts, to get the kind of sentiment, to do proactive information for the agents. All of this is available. And the interesting part here is in how we can get your existing contact center hooked up into this. So we're going to get real-time sentiment, we're going to get trend lines, all of this great information for you. And the way we do that is with a SIP-REC service. So we're going to take a second now and do a demo. So Babu, if you can come back, we're going to set up a demo where we're going to make a call between each other, and we're going to see what that looks like in real time. And so I have an inbound call to me. I'm going to answer that call. Hello, thank you for calling. How may I help you?
Hi, I'm calling regarding a delivery that I was expecting from you yesterday. I still haven't received it. This is really an important delivery, and I'm really frustrated. Could you please help me with that?
I understand your problem. Let me take a look at your account. I see that you're calling from 555-1212, and I see that you've been a very loyal customer of ours. I see that your package has been delayed. Let me see why. And it appears that there was a weather incident in your area. I see that it is set to be delivered tomorrow. And for being such a good customer, I can offer you a $10 credit. Would that make you happy?
Yeah, that's awesome. Thank you so much.
Great. Thank you, and have a nice day.
Thank you. Bye.
And so what you can see here is you can see the trend line analysis as the call is happening. You can see the real-time turn-by-turn of that call as it processes. And so you give both the agent who is processing this call information that they need to do their job, and you can also create a dashboard for your supervisors so that they can notice when calls are going bad and help out with that. It also comes with the ability to have a recording of this available almost immediately. So once the call is ended, we now have a recording of this for future use. So now that we've seen how the live call analytics works with the live demo, we can look at some of the details of what goes into processing this from a live call analytics perspective. The one main piece here that we have is that we're going to take an Amazon Chime voice connector, and we're going to take a phone call into that using SIP-REC. And SIP-REC is it's a standards-based recording for SIP, the session initiation protocol, that we can take and you can fork media off of an existing SBC on-prem, send that up to an Amazon Chime voice connector using SIP-REC, and then we're going to take that that RTP stream and send it over to Amazon KVS. And so this is going to take all of that one-way traffic that you're sending up from your SBC, PBX, whatever, it's probably an SBC. We're going to send that to the KVS, and then we're going to collect that information. So the other side of this KVS stream is going to be, it's called a consumer. And this consumer is going to listen to that RTP and then send that out for processing. So once we know that a call has come in, we detect that via the Amazon Event Bridge. We're going to start off the processes with a Lambda trigger to say to the consumer to say, start listening to the stream. We're going to pick up that stream and we're going to send that stream information over to transcribe. And once we have that sent over to transcribe is going to return that information to us, and we're going to write that over to a DynamoDB table. In the meantime, we're also going to send that over once the call is completed. We're going to send that over to S3 and use an SQS and a Lambda to merge that together and make a recording out of it, so that you've got a nice audio file that you can listen to. It's just an MP3 file. And while that call is going on, we're going to take that data that's being written into the Amazon DynamoDB, and we're going to use AppSync. So there's a GraphQL API in order to pull that information out of there and stream that down into your CloudFront, into your app. So the nice thing about this is that, you know, this information is out here within the DynamoDB, and we have lots of ways of accessing that. So you could build your own app, you could build a mobile app, you could build all sorts of things in order to pull that information out of that DynamoDB using recommendedly with this the AppSync, and we can take that information and populate it in lots of different places within your own app. So this is just kind of a sample. The important parts here are going to be that we use SIPREC in order to get the call from your existing contact center up to KVS. Once we have that in KVS, we're going to process it. In this case, we're using Fargate, but there's lots of ways that you could process that call. Chaining lambdas, you could use ECS, you could use EKS, lots of different ways of consuming that audio stream and then processing it. So for the real-time call analytics, what we have is a fully deployable demonstration. It's deployable via CloudFormation. It's one-click install, and it will deploy all of what you saw into your own account for you. So this does look like a lot of work. This does look like it's fairly complex, and there's a lot going on under the hood. However, we've simplified that for you so that you can experience it yourself and see what we can do. So go ahead, give this real-time call analytics demo a try. It'll build the phone for you. It'll build the Chime voice connector, and it'll build all of the other UI pieces that you saw. As I had mentioned before, the really nice part about this is the way that we can take a existing contact center and use the Amazon Chime voice connector with a SIPREC functionality in order to do this. So you don't have to go out and replace your existing contact center. You don't have to go out and replace some of these pieces. If you can get a SIPREC connection off of your existing contact center through an SBC, through whatever it is that you have on-prem, and send that over to the Chime voice connector, we can ingest that media there and send it over to KVS, which will at that point stream it out, and we can capture it and process it and get you that information back. So the really nice part here is that we don't need to replace a lot of existing equipment. We just need a nice SIPREC interface with you to get this. And right now, we're going to bring Babu back, and we're going to talk about PostCall Analytics. So, Babu?
Thanks, Code. So I'm going to talk about PostCall Analytics now. So first, let's start with why do we even need PostCall Analytics at all, right? So we definitely want to understand our customer well and their journey, and that's very important. We want to be able to answer questions like, where is the customer coming from? Why are they here? What is the best way to solve their problems? And also, we want to figure out how do we use all the data, such as customer journey data, outcomes, voice of the customer, to continuously improve customer experience. Also, we would like to understand the compliance needs, right? Are there certain regulations that we need to meet? Are there some of the script compliances that we need to meet? We can answer these questions, address some of the contact center challenges with PostCall Analytics solution that's powered by AI services. Let's see how. Now, with PostCall Analytics solution, we use few AI services, starting with Amazon Transcribe, that can take call recordings and convert speech to text, providing turn-by-turn transcripts. It can also provide customer sentiment um, from the call recordings, and you can choose to enable redaction of sensitive data such as PII. Transcribe Call Analytics API also provides automatic call categorization feature, using which you can assign specific call categories to each call. And you can also use call summarization feature that can identify the issues discussed in the call, some of the action items that were discussed, and what was the overall outcome of the conversation. All of that can be surfaced through call summarization feature of Transcribe Call Analytics. And then Amazon Comprehend can help you with detecting some of the custom entities from the conversation text. And Translate can convert your text from source language to target language. Now, I want to talk about how do we even deploy this solution, right? So this solution, the PostCall Analytics solution, is available in GitHub for you to deploy into your own AWS account. And within GitHub in the README, you'll see a link to launch this CloudFormation stack. And it can be used to deploy the solution in your own account. Let me quickly show you how to deploy the solution and also demo of how the application works. I'm going to switch over to the browser screen now to show you the GitHub repo. And this is the README file that includes an overview of the solution and an architecture diagram that's also documented here. And we will discuss this in detail. And then you'll find this link to launch stack. When you click this, it will take you to the CloudFormation launch screen, where you need to fill in a handful of parameters. We have already populated with some of the default ones that you can keep as is. But I'm not going to go through each and every one of these parameters, but I'll point to some of the critical ones. Username and then a user email, those two are required because those credentials will be required for you to log into the actual application once you deploy it. We also provide sample call recordings. If you want to include that in the solution deployment, you can enable this so that you'll have some sample files to experiment with right after you deploy the solution. And then we also have a search feature that if you want to deploy that, enable that as well. Now, then the next section of parameters are related to the storage, S3 bucket, where you want to store your input audio recordings, and also for storing output files. You can leave them blank to use some of the default. If you leave them blank, we will create those buckets for you. And then the next set of relevant parameters that you can configure in the solution are related to, let's say, in this case, transcription. Transcribe supports two types of APIs. One is Analytics API. The other one is the Standard API. Analytics API, in addition to converting speech to text, it also provides some of the call analytics, such as sentiment and call summarization, issue detection, etc., that we talked about. You can also support multiple languages that are supported by Transcribe. You can specify those languages here as well. In addition to that, you can configure custom vocabulary and custom vocabulary filters as well. And then, in addition to that, you can also specify the entities that you want to detect in the conversation text. And the other parameters, you can leave them blank, or you can leave them with default values, or configure with whatever values that you want to use. Once you create the stack, the solution is deployed, and then it will output a URL, web URL that provides the front end to the application. And once you access the application from the browser, you will be in the screen of the application that's deployed by the solution. And it starts with a list of calls that have been processed. These are the sample calls that we provide with the solution. And it starts with listing of these calls that have been processed, the file name, the timestamp, and also average sentiment of the customer. And it's important to note that in addition to the average sentiment, we also provide the trend, right? The customer may have had a negative sentiment, but it was trending upwards, which is a good thing, right? So let's take a look at one of these calls. On the top left, we provide the basic information about this call, including the call duration, agent that answered this call. And in addition to that, we also have this average word confidence score, which is the confidence score associated with each and every word in the speech to text conversion. And then we also have created a few charts based on the metrics that we've collected, or the call analytics information that we have surfaced using Transcribe Call Analytics API. For example, we have the sentiment trend that's the customer sentiment starting negative and trending up, and finally ending positive, right? And then agent, you want the agent's sentiment trend to stay mostly positive and neutral. You don't want agents to have negative sentiment, right? And then this chart shows total speaking time between customer and agent. It also shows if there was a silence. It's also an important data that you can take a look to identify if, let's say, for example, if the agent puts the customer on hold for a long time, right, and never comes back. So you can capture bad information from this chart and use that for quality control. And then the additional metrics have been visualized in these two charts here. That includes the speaker volume, basically the blue bars representing the actual speech, and the white spaces representing the silence. And you will see the interruptions that are shown here. Either the customer was interrupting the agent was interrupting the customer. And we've also overlaid the sentiment information on top of these call characteristics. Next section where we're showing entities. So you could use your own custom comprehend model to detect entities, and you can plug that into the solution when you deploy. In this case, the solution has identified these quantities, these vehicle parts and vehicle make from this conversation. And categories we talked about is an important feature within Transcribe Call Analytics that can automatically categorize your calls. And finally, the issue detection of Transcribe Call Analytics identifies the specific issues being discussed in the call. In this case, customer talks about about buying a car and then bumping that into a wall and damaging the door, right? So TCA, the Transcript Call Analytics issue detection feature, identifies that information from the call conversation. And finally, the last section of the solution shows the turn-by-turn transcript. And we also have an audio playback control within the UI, so you can play back the audio that was processed. So as you go through this turn-by-turn transcript, let's say you want to review a specific section within the transcript. If you click on the timestamp, it will automatically take you to that segment within the audio, and you can play back and verify what customer said matches this transcript that's shown on the screen. So that's how the solution works. Now let's go back and deep dive into the actual architecture of the solution. So it starts with customer providing call recordings into S3 bucket, and a Lambda function is triggered, and which then starts the workflow for processing those audio files, and that workflow is implemented within step functions. It's fairly straightforward workflow. So let me show that to you quickly. There's a number of functions, such as detecting the language, the input language, starting the transcription, and then checking if the transcription is complete, and then calling comprehend for the entity detection, etc. It also has error handling. So once this workflow function completes, it will store the output in S3 bucket, also write some of the call metadata into DynamoDB, which is then visualized in the UI. The UI itself is deployed in S3 behind a cloud front, and the application is secured through Amazon Cognito. And that's the UI we just saw in the demo. That's basically pulling information from DynamoDB, which was populated by the workflow. In addition to that, you can also deploy a Kendra search for searching all this call data using the metadata that has been extracted by transcribe call analytics and comprehend. Since this data is available in S3 and DynamoDB, you can use your own BI tools to create your own dashboards and visualizations. Here is a sample that's shown that's been created in Amazon QuickSight. So how do we get started? So we have three ways you can get started with contact center intelligence. So you can use our prepackaged templates that are ready to deploy to quickly identify the value of AI in your contact center. So the three use cases we talked about, those are available as single click, ready to deploy CloudFormation templates that you can try it out. And then we also offer in-person trainings for both technical and business stakeholders through our AWS ML Embark program, as well as full free online training and certification programs for your developers. And in addition to that, we have more than 20 AWS CCI partners who understand how to work backwards from your contact center challenges, and they help you add the right AI capabilities into your existing contact center. They'll find the right solution that can elevate your customer experience and turn your contact center into a profit center. Okay, lastly, here's a set of resources for you. We have a dedicated website for AWS CCI solutions, including links to partner solutions websites, marketplace offerings, and webinars. For each of the use cases that we covered today, you can access demos and quick starts available on GitHub and the AWS YouTube channel. Here is just a sample of some of those resources that you can reference.
Yeah, thanks everyone for coming to our Tech Talk. I will be at the San Francisco Summit in April 20th and 21st. So if you're there for that, love to stop by and talk about all the things that we can do for you. Here's some more information on what we can, some resources that you can use. And yeah, thanks everyone for taking the time to watch.
Thank you.